Today we're exploring the fundamentals of Charles and Boyle's law. So let's start with Charles' law because I feel like it's the easier to understand one. So let's go. Okay, so what does it do? It states the relationship between the volume and temperature of a gas when the pressure is kept constant. So what that basically means is the force that is being exerted on the walls or on the boundaries of where the gas is because when you see states of matter and the gases are really excited, right? The particles are really excited. So they move and they exert force on the boundary that's keeping them in their definite shape. And they obviously don't want to stay in that shape. So that's what pressure is. And when we look at the volume, that's the space it takes up, and the temperature is how hot or cold it is. So it's just the relationship of that. So what did Charles actually found? So he found that when temperature goes up, so does volume. So for the sake of an analogy, here, let me draw an analogy. Imagine a balloon in hot weather. It would probably be about this big, right? Probably a little bit smaller. Sorry. Probably be a little bit smaller. But how would a balloon on a colder day look? That's what we're trying to find here. So it's not letting me click. Sorry. Okay. And then it would probably be a little bit smaller. Probably you would be able to see some more wrinkles on it. That's how usually balloons are. Tell me if you've seen a different one, because that's not very scientific. But, anyways, moving on. That's all about what his law is. It's basically about how if temperature goes up and down, that affects the volume in a proportional relationship. So he even found an equation. He did, in fact. His equation is volume divided by temperature equals to volume divided by temperature. And if you don't understand, I don't blame you. The subscripts were confusing to me too. But they really just mean that one just means the starting temperature of a gas. So, that literally just means that if volume divided by temperature, we said it was proportional, right? So y'all, hopefully your brain understands this, but we all know about the constant of proportionality when you do that. So it's basically if we made a table right over here, and this is our volume and this is our temperature, then our volume times this, or even if you wanted to go, volume divided by temperature, that would also work. That would give you the constant of proportionality. I'm going to call it like K for right now. K, that would give you K. So this part is just equal to K. And so that's what it's saying. K is equal to K. And I'm pretty sure you understand that because they're the same thing. It's like saying 1 equal to 1. Okay, moving on. Okay, so this basically means, yes, what we just talked about, volume over temperature equals constant of proportionality, or just constant, that's for short. Yeah. Okay, so here's Boyle's law, obviously still being presented by Dr. Fuzz. Let's keep going. So what did Boyle find? He found that when you increase the volume, the pressure decreases, and that relation is also proportional, like we learned in Charles' law. So why does it make sense? Well, what he found, sorry, I should have explained this further. He said if you have the volume and you have pressure, for example, right? So when we looked at Charles found the relationship between volume and temperature. Boyle's found the relationship between volume and pressure. So what volume is, he said when the volume of a container, it goes up, the pressure of the gas goes down. And this is also proportional, meaning volume divided by pressure would still give you the constant. I'm going to go X in this time so you don't get confused. Okay? So it still is that way. Because, again, why does it make sense? For example, if you have a balloon and you increase the volume in that balloon, and the volume stays the same, right? Or sorry, the amount of gas you have stays the same. So, and the volume of the container increases, the gas particles have more space to move. So that means fewer collisions with the container walls or like the balloon walls. And so, therefore, lower pressure because pressure is the force exerted on the walls. And when you have more space, that it is more or less likely for collisions to actually happen, which gives us the pressure to become lower. Oh my god, another equation. Yes, there's another equation. So we said, yes, so this is the same one what I was talking about earlier. Um, the pressure divided by the multiplied by the volume equals the K constant. It's our constant proportionality. Again, we can like draw a table to symbolize this. So it says, let's do a practice one. If the pressure is 3.35 newtons and the volume is 2, what is K? So they didn't exactly give us any units, which is totally fine. Let's just do it normally. So here's our pressure table and here's our volume table. Our pressure is 3.35. Sorry, I can't write this. And our volume is 2. So this is actually really easy. 2 times 3.35 is equal to 6.7. And that's our equation, and that would be the answer. So let's check if our answer was right. Yay! So basically, it makes sense, right? So if I had, for example, 2 newtons as my pressure, and my volume was, for example, say it was 15, which is actually quite a big number, but it's okay. It was 15. Then our same K, or constant proportionality, would still be 30. Okay, thank you so much for exploring Charles and Boyle's law with me.